Hello, my name is Chen, and my project is on the effect of paddle angle on the rotation speed of an undershot water wheel. In the increasingly green world today, there has been a large amount of work done to eliminate the reliance of humans on non-renewable energy sources. However, there is still a great reliance on other non-renewable energy sources. This is because most renewable energy sources aren't nearly as cost efficient as those that aren't renewable, such as fossil fuels. And although nuclear energy is extremely efficient, it is also extremely dangerous, as shown in the events of Fukushima and Chernobyl. Therefore, the main problem today is how to improve the cost efficiency of renewable energy sources. This leads to the purpose of my project, which is to increase the efficiency of an undershot water wheel without increasing its cost. I decided my topic would be on undershot water wheels because they are the most eco-friendly and they are the easiest to build since they do not require large building projects such as a dam. The question that was being answered in the experimental process was how will manipulating the paddle angle of a water wheel affect the speed of its wheel rotation. Before we get started, we first need to know some basic background information. In undershot water wheels, the water flows past the water wheel from below, and the water wheel rotates in a direction opposite to the direction the water is flowing. Although undershot water wheels are supposed to be the least efficient out of all three types of water wheels, it does not require a head. The head is water kept at a higher position for the purpose of storing more potential energy in the form of gravity. This makes undershot water wheels much less costly and easier to construct when compared to the other two types of water wheels, since this head is typically in the form of a dam and can be extremely costly to build. In order to understand how a water wheel actually works, one must first understand the forces of torque and drag. Torque is the energy being applied on an object being used to turn or rotate it relative to a certain point. The two main factors that contribute to the torque of an object is the amount of force being applied and the length of the lever arm. Drag is the pushing force that is acting on an object that is being submerged in a fluid. The strength of the drag acting on a surface is closely related to the surface area of the object. Only if these two forces are successfully balanced then will the maximum efficiency of a water wheel be reached. The independent variable of the experiment was the paddle angle of the water wheel, which was 90, 100, 110, 120, and 130 degrees. The dependent variable of the experiment was the rotation speed of the water wheel, which was measured in rotations per minute. The controlled variables were the height at which the water wheel was placed, the size of each paddle, the speed at which the water flew, and the amount of wind in the environment. In order to ensure the precision and accuracy of the experiment was conducted indoors and a system was built to keep all the variables constant. A slope was used to keep the velocity of the water constant, and a pump was used to ensure the amount of water flowing through the system was constant. The system is maintained by a 380 gallon per hour pump, and the way it is designed ensures that there is always a constant amount of water in the system. Each experimental group was tested for 5 times, and the entire experiment was repeated 3 more times for a total of 20 data points for each experimental group. The results showed that the water wheel with a paddle angle of 90 degrees had an average of 8.68 rotations per minute, the one for 100 degrees had 11.3, the one for 110 degrees had 11.75, the one for 120 degrees had 9.7, and the one for 130 degrees had 9.15. This makes the water wheel with a paddle angle of 110 degrees the fastest, the one with 100 degrees the second fastest, the one with 120 degrees the third fastest, the one with 130 degrees the fourth fastest, and 90 degrees the slowest. I also conducted a two-tailed t-test to prove that my data was statistically significant. One might have expected that the water wheel with the highest rotation speed would be the water wheel with 9-degree paddle angle, since it is the deepest into the water and there's the most amount of water pushing against it. However, this isn't all to it, since there's also more water on this side, meaning that this water wheel has to push against more water in order to complete a rotation. However, when the paddle angle is too high, yes, there will be a really great decrease in the amount of drag it's facing over here, but it also faces a problem where there's a lot less water pushing at the water wheel from this side, making it so that the water wheel is inefficient. This is just a visual showing that the size of the water wheel actually gets smaller as the paddle angle increases, and the water wheel with the paddle angle of 110 degrees just happened to have the best balance between torque and drag. These results could be used to construct more efficient water wheels. If future research were to be conducted, I would be testing for the specific degree in which the paddle angle would reach a maximum. This is my logbook. Thank you for watching, and my research paper and my email is in the description.